Welcome to Chapter 15, 15.1 IV Solutions. Alright, intravenous solutions. Fluids are solutions including medications that are delivered directly into the bloodstream through a vein. Blood, a suspension, is also delivered intravenously. Alright, so small error in my notes. I already see two of them. First one, this should be for IV solutions. So in abbreviations for IV solutions, letters identify the component, so what kind of thing it is, and numbers identify the concentration, so how much. Alright, so, first example. In order for 5% dextrose in lactated Ringer solution, that might be abbreviated in any of the following ways. So, one way, we could have D5LR, so dextrose 5 lactated Ringers, or D sub LR, or you could do 5% DLR, and lastly, D5% LR. So, on the table we're going to look at next, there are different ways to use the abbreviations, and it would largely depend on where you're working and who you're working with and what their preference would be. So, for the next one, 10% dextrose in water, we would do D10W, dextrose 10 water. For 5% dextrose in water, it would be similar, so D5W. For water, here's two examples. One, you could just do W for water, or you could be fancy and use H2O. For normal saline, got two options, NS for normal saline, or NSS. For lactated Ringers, do LR. Ringers lactate would be the exact opposite, RL, which makes sense. Alright, so for the 5% dextrose in lactated Ringer solution, we already did that example, so see above. And then for 1/2 normal saline solution, we're just going to do half NS or half NSS. The same follows for the next two. 1/3 normal saline solution would be 1/3 NS or 1/3 NSS. Then 1/4 normal saline would be 1/4 NS or 1/4 NSS. Once again, which one to use would largely depend upon where you are working. So let's look at some other examples. For example 2, how much dextrose is contained in 500 milliliters D5W, which we already knew before was 5% dextrose in water. Okay, so we're trying to figure out how much dextrose, so that's going to be our x value. So let x equal number of dextrose. Now let's take a look at our label right here. So what do we know about dextrose and ml, or milliliters? Well, in 5% dextrose, it's really hard to see here, each 100 milliliter contains 5 grams of dextrose. So we know this. So because we know that, we can go ahead and set up a proportion to solve. So we know 5 grams are 100 milliliters. We can set that equal to, well, we don't know how many grams of dextrose, but we do know we have 500 milliliters. Or at least we're trying to figure that out. Let's go ahead and cross multiply. And we get 5 grams times 500 milliliters equals x times 100 milliliters. Let's go ahead and cancel the milliliters, and in the same step, let's divide by 100. When we do that, cancel those two zeros, and we're left with 5 times 5 grams equals x. So x equals 25 grams. Which means, remember grams is the number of dextrose, there is 25 grams of dextrose in 500 milliliters. Let's look at the next example. Example 3. How much sodium chloride is contained in 1,000 milliliters of NS, so saline solution? Well, we know that each 100 ml contains, it's really hard to see, but that's 900 milligrams. So we know that 100, oops, wrong pen, 100 ml, and there's 900 milligrams. Alright, so we can go ahead and set this up. So let x equal how much sodium chloride, so sodium chloride. And we can set up a proportion, so 900 milligrams over 100 milliliters. It's going to be equal to, we don't know how many grams of sodium chloride, but we do know we're figuring it out in 1,000 milliliters. Let's go ahead and cross multiply. So we have 100 milliliters times x, which equals 900 milligrams times 1,000 milliliters. Okay, we can go ahead and cancel the milliliters. And let's divide by 100 at the same time. When we do that, we can cancel out those 2's between the 100 and the 900, wherefore the x equals 9 times 1,000 milligrams, which is 9,000 milligrams, which is also the same as 9 grams. So we can say 9,000 milligrams are in 1,000 milliliters of NS. Alright, and let's look at the last example, example number 4. How much dextrose in sodium chloride are contained in 1,000 milliliters of D5 half NS? Okay, so one small typo, this should be the word and right here. We're looking at two separate things. We want to figure out how much dextrose is in this amount, and also how much sodium chloride is in this amount. So we're doing two separate calculations. So for the first one, let x equal number of dextrose. We'll solve that. And then we can do, oops, that's a pretty hideous one. There we go, a little tiny bit better. Let x equal number of, or amount of sodium chloride. So we can go ahead and set up the first one, but let's take a look. So we know we have 1,000 milliliters, or we're looking for 1,000 milliliters. We're trying to figure out how much dextrose is in that. How many grams of dextrose? So let's take a look at our label. It says each 100 ml contains 5 grams of dextrose. So we can use that to be in our proportion. We know 100 ml and 5 grams. Okay, we'll go ahead and solve as usual. You can pause the video and try to solve this by yourself. And then check back in with me in a second. Oops, forgot the ml. Go ahead, cancel the mLs. Let's divide by 100 at the same time. Oops. Oh, too many mistakes. Okay. X equals 5 times 10 grams. So x equals 50 grams. So our answer here would be, and let me actually just go ahead and erase a tiny bit of this. So we have 50 grams of dextrose. Let's go ahead and solve the other one so we can finish our answer. Now we have to figure out how much sodium chloride is in this problem. So reading this, it's kind of hard to see, but we have 450 grams of sodium chloride with the 100 ml. Alright, so we can go ahead and set up our proportion using that. We know we have 100 ml has 450 milligrams of sodium chloride. Set that equal to what we know, which is we have 1,000 milliliters, and we don't know how many grams of sodium chloride we have. And you know what, to make things less confusing, I'm actually going to change my variable here. Let's not work with x. let's go ahead and work with, let's call this one Y. Why not? Pun intended. Alright. Ooh, I didn't want black. Alrighty, let's go ahead and solve. You can pause the video once again and try solve by yourself. Or you can follow along with me. 100 ml times Y equals 450 milligrams times 1,000 ml. Go ahead, cancel out the milliliters on both sides. We can divide by 100 at the same time. Use those zeros to cancel. And we're left with Y equals 450 times 10 milligrams. So Y equals 4,500 milligrams. So our final answer would be, there is 50 grams of dextrose and 4,500 milligrams of sodium chloride in 1,000 milliliters of dextrose 5 half NS normal saline. Alright, so the rest of 5.1, go ahead and fill out using the textbook.